All right, guys, for today's lesson, you're going to need this sheet. This is absolute value inequalities. So today we are going to talk about inequalities, but with absolute value. So we've already done inequalities before. We know how to graph those. We've been working on absolute value equations, and today we're going to piece those two concepts together. All right, so I look at this, number one. My goal always is to isolate the absolute value, which it is. So now I come down and I rewrite it like it looks. Okay, now here's the new part. I come down, rewrite the left side, but remember how we change with the absolute value, we change the answer to its opposite? Because I did that, I need to flip the sign. So again, I rewrite one like it looks, and then I rewrite one where I change the answer to its opposite and I flip the sign. Okay, after I do that, then we solve. So times 6, and we get r is greater than 18, and then times 6, and we get, again, r is less than negative 18. So I'm thinking to myself, what kind of graph is this? Okay, so r is greater than 18, so that'd be somewhere roughly about there, shaded to the right because it's greater than, and r is less than negative 18, so somewhere about here, and that'd be shaded to the left. And this is definitely what we call an OR graph because it's got that separation. So my final answer, I put an OR between them, is that, along with my graph up top. Okay, number 2. I go ahead and rewrite it because it is isolated, and then rewrite it, flip the sign, change the answer to its opposite. Okay, then solve. So cancel, so you get x is less or equal to 3. Over here, x is greater than or equal to negative 3. All right, so let's go ahead and think what kind of graph I'm going to have here. If x is less than or equal to 3, it's a close point, and it's going to be shaded towards this direction. But I also have x is greater than or equal to negative 3, so that's going to be shaded, and it's going to be going this direction. Okay, now with this, we only keep what they both share. Okay, so because of that, that's an AND graph. Again, we only keep where the parts are overlapping. You would have technically, this one be going this direction too, and then this one would be going towards that direction too. But the solution set is only where they overlap. Okay, so this is definitely an AND graph, which means we do need to go ahead and reorder that. So to reorder that, take your smallest number, put on the left side. I'm going to flip those symbols, and then take your larger number with that symbol and put it on the right side. So that shows that matches my graph right there. Negative 3 is less or equal to x, which is less or equal to 3. Okay, you guys go ahead and do number 3. And do number 4. Okay, moving down to number 5. Same type of thing, but this time we have a 2-step inequality. So I'm going to go ahead, check it out, and see that it is isolated. So I go ahead and rewrite it. 7 minus 9r is greater than 7. Then come on over and do 7 minus 9r. Flip the symbol, make the answer its opposite. Okay, then solve. So minus 7, you get negative 9r is greater than 0. Divide by negative 9, and r is greater than 0. Okay, subtract 7, cancels. We get negative 9r is less than negative 14. Divide by negative 9, and we get r is less than, it's going to be positive, so positive 14 ninths, which if I change that to a mixed number, that'd be 1 and then 5 ninths. Okay, so say we might have some pretty crazy fractions to deal with, but we'll just estimate kind of where they go on the graph. Okay, so r is greater than 0. That's going to be an open point, and that's going to be shaded to the right. So I know it's going to be going this direction. And then r is less than 1 and 5 ninths. So I got to kind of estimate where it's going to be about halfway, like this, and that's going to be shaded then to the left. So that creates an and graph. So it's a very small little section there. I'll come up top here and write my final answer. So 0 is the smallest number. So I'm going to put that on my left side. So 0 is less than R. And then this 1 5/9 is my larger number. So that's going to go on the right side there. Okay, number 6. Absolute value is isolated. So I have 9 plus 5p is less than 49. And then I have 9 plus 5p is greater than negative 49. All right, let's subtract 9 to both sides. You get 5p is less than 40. Divide everything by 5. P is less than 8. Okay, come over here, subtract 9. Cancels. 5p is greater than negative 58. Divide by 5. Cancels. So p is going to be greater than a negative number, and 5 goes into 58 11 times. 11 times 5 is 55. Remainder is 3. So p is greater than negative 11 3/5. Okay, so think about what this graph's going to look like. Start with p is less than 8. So open point on 8. I know it's going to be shaded this direction. P is greater than negative 11 3/5. So maybe I'll estimate it's about here. And it's going to be shaded then to the right. Again, we only keep the parts that overlap. So it's going to be, this is my solution set right here. Again, this is an and graph. So I'm going to go ahead and place these two pieces together. So take my smallest number, negative 11 3/5. Say less than p, which now put this piece in there, less than 8. And there's our final answer. All right, you guys go ahead and do number 7. Okay, number 8. And let's look at number 9. So number 9 is the first opportunity where we do not see the absolute value bracket isolated. Okay, so in this case, I want to go ahead and do that first. So I'm going to divide by 2 to get rid of this 2 in front. Come over here, divide by 2. Now, when I do that, I have the absolute value of x over 2 is greater than or equal to 3/2. And I'll just leave it as improper right now. Now I'm going to come over here and I'm going to rewrite it. X over 2 is greater or equal to 3/2. And then x over 2, flip the sign, make it its opposite. All right, so now I just solved. So I'm going to multiply both sides by 2. So that cancels. So I have x is greater or equal to, these 2's cancel, 3. Come over here, multiply by 2, cancels. X is less or equal to, again, that cancels, negative 3. All right, so let's go graph that. X is greater or equal to 3. So it's a closed point. I know it's going to be shaded there to the right. X is less or equal to negative 3. Closed point, shaded to the left. So those are going to be OR graphs. So don't forget, I'll put arrows on the ends. And that's my graph there. I don't need to rewrite anything. I just put the word OR between those and circle it up. That's my answer. Okay, number 10. Again, the absolute value bracket is not isolated, so I'll go ahead and fix that first. I'll subtract 3 to both sides. And when I do that, I'm left with the absolute value of negative 4b plus 5 is less or equal to 7. Okay, now I make my two different equations. Flip the symbol, make its opposite, and then let's solve. So minus 5 cancels. Negative 4b is less or equal to 2. Divide everything by negative 4. Now, don't forget the rules. When you divide by a negative, at that point, that inequality symbol needs to flip. So I'm going to flip that symbol around, and 2 over negative 4 will reduce to negative 1/2. Come over here, subtract 5. Cancels. So you got negative 4b is greater than or equal to negative 12. Okay, then divide everything by negative 4. Again, we got to remember our rules. Divide by a negative means this symbol flips, and that gives me 3. Okay, so I have b is less than or equal to 3. I have b is greater than or equal to negative 1/2. Okay, so here's negative 1/2. I know that's going to be shaded to the right. B is less or equal to 3. There's that. That's going to be shaded to the left. So that gives me an and graph. Okay, let's piece those back together for my final answer. Take my smallest answer, put it on the left side, flip the symbols there like that, and then add this last piece in. So there's my and graph. All right, you guys do number 11. Go ahead and do number 12, number 13, and last, number 14.